And now, a pitch presentation on XiL testing, featuring Anish Anthony, Vice President of Product Management at Concurrent Real-Time. Discover how XiL methodologies are reshaping automotive testing, enabling faster innovation and reduced costs. Learn about Concurrent Real-Time and VI-grade's latest offerings for XiL testing across the real-time spectrum.
Hello, everyone. It's a pleasure to be here and listening to all the presentations talking about XiL. And so I'm going to talk a little bit about concurrent real-time. And you've heard the name concurrent real-time, VI-grade, simulation workbench, in a lot of presentations. So essentially, our teams at Concurrent Real-Time and VI-grade are constantly trying to give you the latest and greatest in terms of solutions to all the cool things that you're trying to do. Okay? So Concurrent Real-Time and VI-grade are part of the same group under HBK. We are different divisions focusing on slightly different things, where our core mission is to give you the best real-time solutions for the awesome presentations that we've seen so far. And so my pitch is going to be, look at concurrent real-time and VI-grade solutions to increase your efficiency, leverage the flexibility that we offer for all your XiL needs. When I talk about real-time, I start with this slide about real-time spectrum, which includes different levels of responsiveness in computing systems. At one end, we have non-real-time systems where the response times are not that critical. At the other end of the spectrum, we find that real-time systems where we have stringent timing requirements, where missing a deadline could lead to system failure or even endanger lives. Understanding this spectrum is crucial when designing and implementing real-time systems, as it dictates the level of precision and reliability needed in the underlying software and the hardware components that you use to build these real-time systems. So the mantra of model-based design is what? Test early, test often. And as we journey from requirements to deployment, we see that we are moving from modeling and simulation to software-in-the-loop testing, to real-time simulations, and then into hardware-in-the-loop studies for ride and handling, NVH, ADAS, AV, HMI, right? We've seen all these slides being yesterday and today in different presentations. And then from there, moving to dynamic driver-in-the-loop simulators. And the first time ever I heard this term, twin-in-the-loop, yesterday in the presentation. And that was exciting because we are talking about XiL, where X can stand for anything. So the twin-in-the-loop for vehicle predictive controllers. And we realized that, what do we realize? That different compute engines are required to satisfy customers' real-time requirements. And here is a table that I've put together based on my experience on the different compute engines that you will need for modeling and simulating different aspects of the vehicle under development. And so what we offer is we need the latest and greatest technology in terms of compute, in terms of GPU, in terms of FPGA, and an integration of all these architectures to enable optimized real-time performance. We are, and maybe the only solution out there which supports the latest and greatest NVIDIA GPUs with drivers optimized for real-time performance, not only for graphics, okay, but also for CUDA, which brings me to AI in the loop. So another part of that X is AI in the loop applications. And so at Concurrent Real-Time and VI-grade, what is our goal? Our goal is understanding the customer's requirement. And based on our expertise and experience, recommending and providing the best-in-class solutions to them. And I want to highlight a couple of solutions here. Our teams have done a great job presenting that in the tent. So I would recommend during your coffee break, come by, stop, talk to us, and look at the demos that we have running in the demo stations there. So I would like to introduce a brand new product, which is called Simulation Workbench for Windows. So a lot of you are already using Simulation Workbench. And so what we have done is we have taken that Simulation Workbench and added DriveSim and its capabilities to run on a desktop or laptop under Windows subsystem for Linux. And so in this case, we are able to run VI WorldSim natively on the Windows system and VI Car Real-Time under the Sim Workbench environment on your Windows development system. So what does this help? This helps in an efficient development process for preparing your complex models before you deploy it into your very expensive asset, which is your hardware-in-the-loop system or a driver-in-the-loop system. And so now the development teams and groups of developers, which are working on different subsystems, can test and gain the confidence in their model before you integrate and test it in the production environment or towards your DIL system. Next, I'm super excited to showcase the only system of its kind we have successfully built, which for marketing purposes I'll call AutoHawk Extreme. And this is the most powerful real-time computer based on commercial off-the-shelf hardware that we are showcasing in the Dassault demonstration area. As the gamers in the group know that overclocking is an art. And to create this system, we had to go through few sets of components and 2 months of trial and error and experimentation to create a liquid-cooled overclock system which could run a very complex customer model below 700 microseconds. So if you see the numbers on the screen, the model was running at around 1250 microsecond, which is our typical real-time loop is 1 millisecond. We want to be below it. And we couldn't do it with the latest and greatest. So we really have to think out of the box, come up with innovative solutions. And we did a lot of experimentation to come up with that liquid-cooled system, which could run the model around 690 microseconds. And you can see it in the booth running. So now you have enough room to add tire models, other control system models, Simulink MATLAB models into the loop and still be able to be within that 1 millisecond realm. Here's a picture of that system. Again, I couldn't find a system wide enough to do the cooling. And so I had to go with a gaming system. But the next goal is to probably find a chassis to be industrial and rack-mountable chassis. The next and the most powerful thing that we have is our next-gen FPGA card. So we already have the latest CPUs, Intel, AMD, or ARM that we support, and the latest GPUs from NVIDIA. So we had to build this new FPGA card. So I have this card in the ECU Hill demo area under the tent. And so if you want to stop by, we can talk. But this gives you the flexibility of not only programming the firmware on the FPGA, but also we have the daughter board concepts where we can change the hardware based on what your requirements are. And the beauty about this solution is that you don't have to be an FPGA engineer to use this. So all of you can program the board to take your models that require that nanosecond model cycle, the real-time loop, and put it on the FPGA, and then get it to work throughout the ecosystem with AutoHawk, Red Hawk Linux, Simulation Workbench, through VI DriveSim. And I would strongly encourage you to come back during your coffee break, talk to the engineers. The engineers at VI-grade have done an excellent job putting the demonstrations together. OK, so thank you all for your time. And I'll look forward to talking to you in the demo sections.